Hi students, the question is prove the statement 1 plus 2 plus 3 etc. up to plus n is equal to 1 by 2 into n plus 1 by using the principle of mathematical induction. So here we have to prove this statement by using the principle of mathematical induction. So before proving it, we have to know how we will prove by using the principle of mathematical induction. What are the steps involving in mathematical induction? So here this is the method. First, you have to prove the statement for n is equal to 1. That is the base case. So for n is equal to 1, we have to prove the given statement is true. Next is the inductive step. So inductive step means we have to assume for n equal to k. For n equal to k, we have to assume that the statement is true. That statement holds for n equal to k. We have to prove for the next value for n is equal to k plus 1. For n is equal to k plus 1, we have to prove the statement. So if it is proved for n equal to k plus 1, then we can say in general the given statement is true. So these are the steps in mathematical induction. So here the question is, the statement here given it is 1 plus 2 plus 3 etc. up to plus n equal to 1 by 2 into n plus 1. So first we have to take the given statement as p of n. So let p of n be the given statement. So given statement is 1 plus 2 plus 3 etc. up to plus n is equal to 1 by 2 into n plus 1. So first is basic step. So basic step means we have to prove for n is equal to 1. So in the place of n, for LHS, in the place of n we have to replace 1. So for LHS here n, so in the place of n we have to replace 1. Therefore LHS the value is 1. Similarly for RHS, in the place of n we have to replace 1. Therefore 1 by 2 into, for n the value is 1. 1 into n plus 1, 1 plus 1. So which is equal to 1 by 2 into 1 plus 1, 2. So 2 and 2 get cancelled, which is equal to 1. Therefore LHS is equal to RHS. Therefore we can say that the statement is true for n is equal to 1. Therefore for p of 1, the given statement is true. So next is the inductive step. So in inductive step we have to assume that the statement is true for n is equal to k. Therefore the given statement becomes 1 plus 2 plus 3 etc. up to plus k is equal to 1 by 2 into k plus 1. In the place of n we have to replace k. That is the inductive step. In inductive step, so we have to assume p of k is true. So we have to assume p of k is true in the inductive step. So p of k means the given statement becomes 1 plus 2 plus 3 etc. up to plus k is equal to 1 by 2 into k plus 1. So this is the inductive step. In that we have to assume p of k is true. And we have to prove p of k plus 1. P of k plus 1 is true. That is we have to prove. So therefore p of k plus 1 means the statement becomes 1 plus 2 plus 3 plus etc. up to plus, this is the kth term. Next the k plus 1th term, so which is equal to 1 by 2 into, in the place of k it becomes as k plus 1 into, here for k plus 1, therefore that k plus 1 plus 1, therefore k plus 2. This is the statement we have to prove. Consider the LHS of this p of k plus 1. So that left hand side is 1 plus 2 plus 3 plus etc. up to plus k plus 1. So which is equal to, so here 1 plus 2 plus 3 etc. up to plus k, the value is 1 by 2 into k plus 1. Therefore for that we have to replace the value 1 by 2 into k plus 1 plus the next term is k plus 1. So next we have to take the LCM. So here the LCM is 2, therefore denominator 2, the numerator k into k plus 1 plus, for this term it is 2 times 2 into k plus 1. So which is equal to 1 by 2, the half as we can take out. K, if you multiply the k inside, k into k square plus k plus 2 into k, 2k plus 2. So which is equal to 1 by 2 half into k square plus k plus 2k, it is 3k plus 2. Now we have to factorize this k square plus 3k plus 2, that is sum 3 and multiply. When we multiply the value, it should be 2. Therefore this factorization is 1 by 2 into, for this k square plus 3k plus 2, the value is k plus 1 into k plus 2. So this is what we have to prove. If you see the right hand side of this, it is 1 by 2 into k plus 1 into k plus 2. That is we have to prove. Therefore we got that value 1 by 2 into k plus 1 into k plus 2. Therefore the statement is true for p of k plus 1. The statement is true. Therefore in general we can state that given statement is true for n. Therefore p of n is true. Therefore, the given statement 1 plus 2 plus 3 plus etc. up to plus n is equal to 1 by 2 into n plus 1. This is the way we have to prove by using the principle of mathematical induction. Thank you.